Hello, this is our video on solving equations algebraically. Last week we focused on solving equations with the sketch method, and this week we're transitioning to solving equations algebraically. Same type of equations, we're starting with variables on both sides. So 4x's plus 5 equals 2x's plus 9. But instead of the sketch method, we're going to use algebraic methods. And one of the things that we're going to focus on with algebraic method is it is the same basic principles in that we have to isolate our x's. So we would draw the line just as we did before, and then we have to figure out what one x equals, or when we did the sketch method, one triangle. But to do that algebraically, instead of sketching it and getting a visual, we're going to use opposite operations. And what I mean when I say that is addition is the opposite of subtraction, so that if we notice that things are connected through addition, we subtract in order to isolate our x. If we notice that things are connected through multiplication, we use division to isolate our x, and vice versa, because we're always using opposites. And then the other thing that we're going to use is an essential rule of math dealing with how both sides work. This equation, 4x's plus 5 on the left equals 2x's plus 9 on the right. It is a balanced equation. Both sides are equal to each other. And you can do anything you want to the equation as long as you do it to both sides. Because if I added, say, 10 to the right side, then they wouldn't be equal anymore because they're equal as they are. So if I add 10 just to the right, it's unbalanced. In order to make it balanced, I would have to add 10 also to the left. And if I do that to both sides, then it's balanced. And that may or may not help solve it, but it keeps it balanced. And in order to solve it, we have to use opposite operations and we have to keep it balanced by doing the same thing to both sides. And the method that we are going to use to solve this equation is called the DCID method. Distribute, combine like terms, isolate the variable using addition or subtraction, and then the last step, divide. And actually the last two steps are what we're going to focus on. We will be looking at distribute and combine like terms in later lessons, but they are not a part of the problem today. So I'm just going to mark them off, and we're going to be focusing on the last two. And in fact, both of the last two steps involve isolating the x, getting the x by itself, but the first one, just to isolate with the plus or the minus, because if we have to isolate with addition or subtraction in the problem, we do that first. If we have to isolate through division or by dividing, we do that last. Now, you don't always have to do all these steps, and in fact, today we're only going to be looking at the last two, but if you do these steps, this is the order that you go through them. So we're going to be looking at this equation. I've already drawn a line, but I'm just going to keep drawing it down here. And I am going to show how the sketch method relates to this so that we can see how one relates and transitions to the other. So I'm going to sketch down low here. Okay, it says 4x's, and our x variable is our triangle. So I'm going to make 4 triangles. And then it's got the 5. That's a constant. It's a number without a variable, so a 5 cubed. And then on the other side, I've got 2x's, so 2 triangles, and a 9 constant, a 9 cubed. So that's the visual representation of this problem. Now, when we solved it sketch method wise, we said, okay, if there's triangles on both sides, we need to get all the triangles to one side. We need to isolate. So we said, okay, if I've got 2 triangles here and 4 triangles there, I can take triangles off. I can do it one at a time as long as I follow that essential rule of doing the same thing to both sides like that. Or I can say, well, you know what, I can take off 2 triangles on the left, then I have to take off 2 triangles on the right, and you can do it all at once. That same method applies algebraically up here at the 4x plus 5 equals 2x plus 9. So if I'm going to do it algebraically, sort of applying that concept, I look at my x's and I say, I need to get my x's together. And I always go to the side that's got the fewer x's, just like I could take away 2 triangles because that was the fewest number of triangles on a side. I look at that 2x side and say that's the fewest number of x's. So I can take off those triangles. And taking away is subtraction. So I'm going to subtract 2x. But if I do it on my right side, then I also have to do it on my left side to maintain the balance. So it's the same thing algebraically as it is visually. Algebraically, it was easy to see that you're taking it off because you're actually just marking through and getting rid of it. But if you look at it algebraically, you might wonder, well, why are we subtracting? Because this isolate step here that we're doing says plus or minus. Well, it depends upon how things are connected and represented. That 2x in black in the problem is positive, and think of positive as plus. And remember, we use opposites. So the opposite of a plus is the minus. So in order to get it off of there or take it away, we're going to be subtracting. So then I do 2 minus 2, and it goes away. That makes 0 x's. And then on the other side, I do 4 minus 2, or 4x's minus 2x's, and I get 2x's. Just like down here, I had 2 triangles left, and the triangles represent the x's. Now I have 2 x's left. I'm just going to keep sort of sketching and going back and forth. I've got my 2 triangles left, but we also sketch what else we have left. We have the 5 cube left, and then we have the 9 cube left on the right-hand side. Well, if I sort of go back up my algebra, I apply that same thing. I've got my 2x, but I still have that plus 5 there, so I'm going to bring it down because it's still there. And then on the right side, I've got the 9. I'm going to bring it down as well because it's still there. Now, I don't have to put the plus 9 in front of it, or the plus sign in front of the 9, because as long as there's no symbol in front, it's understood to be positive. So I've just done my first isolation step. Now I'm going to go back to the sketching, and I can't take away x's anymore, or triangles, but I can look at it and say, well, I've got cubes on both sides. So I need to get cubes just to one side, away from the triangles. So we go to the triangle side over here and say, okay, well, if I want the triangles by themselves, then I need to take away that 5. And if I take away the 5 from the left side, now I have to take away the 5 cube from the right side. Well, we do that same process up here. It's not quite as obvious visually because what we're trying to do is get this x by itself. And it's not only a 5 that we see connected to the x, there's also a 2. But the 5 is connected with an addition sign, and the 2, well, there isn't anything in between the 2 and the x. If there is no symbol in between them, then it's connected through multiplication. That's 2 multiplied by x. And remember, if we're going to do this isolate step, okay, if there is an addition or a subtraction, we do that first. And there is. We've got a plus sign there. We've got that plus 5. So we're going to move the 5 first. And the opposite of plus is this minus again. So in order to get the 5 away, I'm going to subtract the 5, just like I did with the cubes. I took it away, and 5 minus 5 is 0. And then I have to subtract it onto the other side because I have to do the same thing to both sides. And then I'm just going to keep going. I'm going to say, okay, 9 minus 5, that gives me 4. And just like before, I'm going to bring down that 2x because it's still there. And I'm going to look at my sketch and say, okay, when I was sketching it, I've got 9 cubed minus 5 cubed. That would be a 4 cube. And I've got my 2 triangles left. So I see we have the same representation. I've got 2x plus 4 and up top in the algebra, and then I've got 2 triangles equal to 4 cubed. So it's the same representation. Now, when we were doing the sketching, we went to guess and check, and we had to try to figure out what number would go in for both triangles, and we don't actually have to do that if we're going to do it algebraically. I can't just add or subtract anymore to isolate because I don't have anything connected with a plus or a minus sign, but I still need to get this x by itself, so I need to get that 2 away. And remember, the 2 is connected with multiplication. Well, the opposite of multiplication is division, so we're going to divide. We're at that last step. So I need to divide this side by the 2, and 2 divided by 2 is 1, so I have 1x left. But then I have to do the same thing on the other side. I have to divide by 2, and 4 divided by 2 is 2. So I have 1x equals 2, and 1 is the same thing as just an x, so the 1 can just become my box. So my answer is x equals 2. And if I want to come down and look at the sketch, remember one triangle is an x, so I'm saying that this triangle is a 2, and the other triangle is a 2. And if we add them together, oh yes, 2 plus 2 equals 4. So I get a 4 on the left side and a 4 on the right side. Well, that means that my answer works. That means that that one triangle is a 2, and a triangle is the same thing as an x. So yeah, the x was a 2. It works either way.